You know, we are living through one of the most incredible technological shifts in human history, and right at the very center of it are two key figures, kind of like the architects building the foundation of our future. One of them created the engine, the hardware. The other is building the intelligence, the software. What they're doing is setting the stage for the next chapter of humanity. So let's break down how we got here.
Just let that sink in for a second. That's the reality laid out by Sam Altman, the CEO of OpenAI. It's a pretty startling statement, right? And it really captures the insane stakes of this AI revolution. This isn't just another cool gadget or app. This is a fundamental change to the landscape of intelligence itself.
So, how on earth did we get here? How did we get to a point where we can even talk about a machine that could potentially outthink us? Well, to really understand what's happening now, we have to rewind the clock. About 30 years. To a big idea that had absolutely nothing to do with AI and everything to do with video games.
Okay, this is where Jensen Huang, the CEO of NVIDIA, enters the story. Back in the 90s, he and his team made this enormous bet on a totally different way of thinking about computing. It was a bet that would take decades, literally decades, to fully pay off.
The big insight was this. You see, most computers back then used a CPU, a central processing unit. And a CPU is a genius at solving one big problem at a time, very methodically, step by step. But NVIDIA, they focused on the GPU, the graphics processing unit. And that's a whole different beast. It's designed to solve thousands, even millions of little problems all at the exact same time.
NVIDIA's owned team had this brilliant analogy for it. Imagine you're trying to paint the Mona Lisa with a single, super precise paintball gun. Ping, ping, ping. That's a CPU. Now imagine a massive wall with thousands of paintball guns all firing at once to create that same image in an instant. Bam! That's a GPU. That's the power of parallel processing.
So why start with video games? Well, like Jensen Huang says here, it was the perfect testing ground. I mean, it was a huge market, which meant it could fund all the crazy expensive research and development needed to build these chips. This created what you'd call a flywheel. Better games funded better chips, which then enabled even more amazing games. And that flywheel was about to start powering something else entirely.
So here's the big leap. How did we get from making awesome virtual worlds in video games to actually building artificial intelligence? Well, the key was figuring out how to unlock all that parallel processing power for stuff that wasn't just, graphics.
This timeline pretty much shows you how all the dominoes fell. After that big insight in the 90s, NVIDIA built a platform they called CUDA. They basically gave programmers the keys to the kingdom, letting them access all that raw power. And then 2012 happened. This was the moment that changed everything. A neural network called AlexNet, running on NVIDIA GPUs, didn't just win an image recognition competition, it absolutely demolished it. That was the starting gun for the AI race that we're all into.
And this is the absolute heart of the revolution. AlexNet was the moment we stopped telling computers exactly what to do, step by step, and instead, we just started showing them, with massive amounts of examples. We weren't programming intelligence anymore, we were training it. And GPUs were the only engines on the planet powerful enough to handle that training.
Which brings us right back to today, and back to Sam Altman. His company, OpenAI, took that whole training idea and just scaled it up to a level that is almost impossible to imagine. And that's what's led to these incredible models, like the next generation of GPT.
So, just to get our bearings, let's remember what the previous model, GPT-4, could already do. We're talking superhuman performance. It was acing some of the hardest exams humans have ever come up with: law, medicine, coding, even becoming a master wine expert. And yet, Sam Altman calls this the dumbest model any of us will ever have to use again. Wild, right?
So what's different now? Well, according to Altman, the new generation of models has taken a huge leap in its ability to reason. But the real game changer is how that reasoning can instantly translate your ideas into reality. It can create complex working software just from you describing it. This just changes the entire creative process.
I love this story. Altman talks about how as a kid, he spent hours and hours programming a simple snake game on a calculator. Hours of painful work. GPT-5 did the exact same thing in 7 seconds. 7. The struggle, the tedious part, is just gone. The whole process shifts from painful execution to just this rapid-fire expression of your idea.
Okay, so we have these two massive forces, right? Jensen Huang's hardware revolution and Sam Altman's intelligence revolution. When you put their visions for what's next together, you get two pretty distinct but also connected pictures of our near future. Huang sees a future of physical AI.
He's convinced that everything that moves will eventually be robotic. Cars, factory arms, maybe even humanoid assistants in our homes. And here's the wild part. They'll learn how to operate not by bumping into things in our messy world, but by being trained in perfect digital copies of the real world, virtual simulations, all running on NVIDIA hardware.
Altman's vision is more focused on digital intelligence. He imagines an AI that doesn't just answer our questions, but actually speeds up the whole process of scientific discovery itself. Think about that. An AI that could do research better and faster than the best human teams, tackling humanity's biggest challenges, like curing diseases.
You know, this all points toward the long-term goal for a lot of people in this field, something they call superintelligence. It's not just about a smarter chatbot. It's about creating a tool so incredibly powerful it could help us solve problems that, until now, have been completely impossible for us to crack.
But of course, when you try to build something this powerful, you're sailing into completely uncharted waters. And it forces us all to confront some incredibly difficult, profound questions about what our future is going to look like.
Jensen Huang raises such a critical point here. An AI can learn a fact, right? Like the boiling point of water. But truth? Truth is about what things mean. It's personal. It depends on your culture, your values, your context. So how in the world do you build a system that can understand the nuances of humanity without just forcing one single worldview on everyone?
And with any massive technological jump, there's always disruption. The Industrial Revolution was messy, it was difficult, and it completely transformed society over, 100 years? Some experts predict this AI revolution will be 10 times bigger and happen 10 times faster. Living through that kind of change is going to be a challenge like nothing we've ever seen before.
So what's stopping us from getting to that future tomorrow? Well, it really boils down to three main bottlenecks. There's compute, and specifically the absolutely massive amounts of energy we need for these data centers. Then there's data. The models have basically read the whole internet. Now they need to discover brand new knowledge. And finally, there's algorithms. We just have to keep getting smarter about how we build these things. But maybe the best way to think about all of this is Sam Altman's analogy, the transistor. The companies that made the first transistors, sure, they were important. But the real revolution, the magic, came from what everyone else built on top of them. AI isn't the final product. It's the new foundation.
And that really brings the question right back to us. For centuries, people have added their own brick to this long path of human progress, building the world that we all stand on today. So with this powerful new foundation being laid right underneath our feet, the real question for all of us is, what brick will you add?